Astronomers are suggesting that hot rocky exoplanets may have water-rich atmospheres. Through the use of research data, they are suggesting that 80% of hot rocky exoplanets may have water-rich or hydrogen and oxygen atmospheres. These exoplanets are rocky planets with orbital periods less than 100 days. They are formed as gas-rich sub-Neptunes that eventually lose most of their atmospheres, but as to whether these exoplanets still have atmospheres is an unknown phenomenon. In a recently published research paper, astronomers predicted that rocky exoplanets with orbital periods between 10 and 100 days still retain a water-dominated atmosphere. What they already know from NASA's Kepler mission is that planets a little smaller than Neptune are really abundant throughout the universe. This was a surprise to astronomers because there are none of these sub-Neptunes in our solar system. They don't know for sure what they are made of, but there is strong evidence that these sub-Neptunes are magma balls cloaked in hydrogen atmospheres. There's also a large number of rocky planets that are smaller but are quite similar to these sub-Neptunes. However, they don't have the hydrogen-cloaked atmosphere. Scientists have also surmised that many planets probably start out like these larger planets that have atmospheres made out of hydrogen, but lose their atmospheres when their nearby star ignites and blows away the hydrogen. There is not a lot of detail available in regards to this assumption, but it remains to be identified after observations have been made from the computer modeling. They have also explored the potential consequences of these planets having been covered by oceans of melted rock. As stated by astronomers, liquid magma is actually quite fluid, so it also turns over vigorously, similarly to the oceans on our Earth. There's also a huge possibility that these magma oceans are draining hydrogen out of the atmosphere and reacting to form water. Some of that water escapes to the atmosphere, but much more gets slurped up into the magma. Then, after the nearby star strips away the sub-Neptune's hydrogen atmosphere, the water gets pulled out into the atmosphere instead in the form of water vapor. Eventually, the planet is left with a water-dominated atmosphere. At this stage, this phase could persist on some planets for billions of years. Based on what the research team predicted, this is imminently testable with the upcoming James Webb Space Telescope. The James Webb Space Telescope will be launched later in 2021. It is the powerful successor to the Hubble Space Telescope. The James Webb Space Telescope will be able to conduct measurements of the composition of an exoplanet's atmosphere. If it detects planets with water in their atmospheres, that would be one very important signal. Another strategy that will be utilized is to look for indirect signs of atmospheres. Most of these planets are tidally locked. Unlike Earth, they do not spin as they move around their host star. So one side is always hot and the other side is always cold. Based on the research, the atmospheres of these exoplanets formed during the planet's evolution from sub-Neptunes into rocky exoplanets. Water that is made by the reduction of iron oxides in the silicate magma is highly soluble in the magma, forming a dissolved reservoir that is protected from loss so long as the H2-dominated atmosphere persists. The large size of the dissolved reservoir buffers the water atmosphere against loss after the H2 has dispersed. Within their computer modeling, a long-lived water-dominated atmosphere is a common outcome for efficient interaction between a nebula-derived atmosphere at a peak atmosphere mass fraction of 0.1 to 0.6 and an oxidized magma followed by atmospheric loss. This idea predicts that most rocky planets that have orbital periods of 100 days and less have radii within 0.1 to 0.2 Earth. Off the lower edge of the radius valley will still retain water-rich atmospheres. This prediction will be testable with the James Webb Space Telescope, and the implications will be provided to astronomers and researchers alike so that they can interpret the data to be used to analyze transiting super-Earths. Thanks for watching and goodbye.